So for this investigation, we're going to be talking about the reason for the season. And there's actually a few key reasons why we have seasons. But the first thing we need to talk about before we can even get into seasons is this idea of latitude. We've already covered latitude in a previous investigation, but I just want to review it. Latitude is simply the distance in degrees from the equator. And if you wanted to know technically why it's called degrees, basically the way it works is that if we were to draw a line between the equator going through the core of the Earth and then another line from the core of the Earth out to a particular latitude, the angle between those two lines would be the number of degrees. That'd be the latitude. You don't need to know that. All I want you to know is that low latitudes have very small numbers. The equator itself has a latitude of 0, and then these lower latitudes, 5, 10, 20 degrees, are closer to the equator. On the other hand, the further away you get from the equator, the larger the number becomes. And then once you hit 90 degrees, you're either at the North Pole at 90 degrees north, or the South Pole at 90 degrees south. And sometimes instead of saying 90 south, they'll say negative 90. But it's the same idea. Why would that relate to seasons? Well, the reason why is because of something called the angle of insolation. So, have you ever wondered why the warmest time of the day is usually afternoon? Well, the reason why is because the sun is highest in the sky right before the longest time of the day. And I don't want to contradict something that I talk about in my lecture class that's beyond the scope of this. Warmest time of the day is actually mid-afternoon, usually between 3 to 5 p.m., but we actually receive the most sunlight at noon. And the reason why is because the sun is highest in the sky. When the sun is highest in the sky, that means that the radiation that's actually hitting the ground isn't being spread out over a large area. Instead, it's being concentrated. And this means that it's intense. If you want a good example of this, go into a dark room with a flashlight and shine the flashlight directly overhead from a table or from the ground. And you'll notice that the flashlight, the beam of light creates a small, bright circle. Now take that same flashlight and begin to lower it on the horizon so that the light is hitting the ground at an angle rather than coming directly overhead. Instead, you're lowering it on the horizon, it's coming in at a lower angle. Well, what happens is this causes the light to spread out. Well, you have the same amount of light, but now it's spread out over a larger area. That causes it to be more diluted. As a result, not as intense. So basically all I'm saying here, higher in the sky, more intense, lower on the horizon, more diluted, therefore it's not as intense. You're not receiving as much heat. Now, what does this have to do with latitude? Well, I'm glad you asked. Here's what it has to do with. Twice a year, the sun is directly over the equator. And then as the Earth orbits the sun travels a little north of the equator and a little south of the equator. And we'll actually cover that in another video. But that being said, areas near the equator have the sun high in the sky. So the radiation they receive is very intense. On the other hand, if you're at a higher latitude, closer to the pole, the sun is always going to be lower in the horizon. Hence, the sunlight is more spread out. It's not as intense, therefore you don't get as much heat. So if you're near the equator, sunlight is directly overhead. As a result, more intense. If you are at a higher latitude away from the equator, the sun is lower on the horizon and therefore much more spread out, not as intense. And this actually creates an interesting consequence. And pretty, I'm sure that you might think this is kind of a duh consequence. But areas near the equator, which get that most intense sunlight, are on average the warmest places on Earth. There's some other things that actually make desert regions a little bit warmer, but that's beyond the scope of this discussion right now. But just know, lower latitudes near the equator, much warmer. On the other hand, the further away you go from the equator, these reds represent warmest. Further you go away from the equator, lower in the sky the sun is, less intense, cooler. You get into those blues and purples, which typically indicate much cooler temperatures.